Lesson 8b, Impulse. Impulse is denoted by the symbol delta p. The Greek letter delta means change. Impulse is the change in an object's momentum. From last lesson, we know that momentum is mass times velocity. So for momentum to change, either mass or velocity will have to change. Although it is not always the case, most often when an object travels, its mass does not change or its change is negligible. For most of our calculations in Physics 11, a change in momentum will be due to a change in velocity. The object will speed up or slow down. When calculating change in a measurement, it is always final measurement minus initial measurement. In our case, it's final momentum minus initial momentum. If delta p impulse is p final minus p initial, and p is mass times velocity, then impulse is mass times final velocity minus mass times initial velocity. If mass stays constant or its change is negligible, then factoring out the mass leaves us with impulse equals mass times final velocity minus initial velocity. Impulse equals mass times change in velocity. Let's look back at our 140-gram baseball traveling at 126 kilometers per hour. We converted the mass and the velocity to proper SI units, and then we plugged those values into our momentum equation. We calculated momentum to be 4.9 kilogram meters per second. Our question for this lesson will be to determine the change in momentum, or the impulse, that a bat would deliver to the ball if the bat struck the ball and the ball now moves with a velocity of negative 45 meters per second. Remember, with vectors, the negative means that after the ball was struck, it is now moving in the opposite direction to its original direction of travel. This happens quite often in Physics 11 when an object's direction changes, so it's important to keep track of your positive and negative signs on your vectors. Delta p equals m times delta v. Subbing on our values of 0.14 kilograms times negative 55 meters per second minus 38 meters per second makes 0.14 kilograms times negative 93 meters per second. Delta p is minus 13.02 kilogram meters per second. Or using equivalent units that are commonly used for impulse but not commonly used for momentum, we get impulse equals negative 13.02 newton seconds.